I am Sharon Megdal speaking to you today from the United States. I am director of the Water Resources Research Center at the University of Arizona, and I'll be speaking about some of the wicked water problems we are tackling in the Transboundary Colorado River Basin, particularly due to climate change and increasing aridity. I direct a center involved in applied research, education, and engagement at the University of Arizona. And I invite you who may be interested to check out our website and possibly subscribe to our weekly wave, which informs you of programs that we sponsor, webinars that we record, most of which are free of charge. I am a student of water policy and management. In fact, I teach a graduate course each spring on the subject of water policy in Arizona and semi-arid regions. And this slide is one that I use in the first class and in many presentations that I give. It is important to recognize the many factors that affect water policy and management. I underline a few of them here because the legal institutional framework are so important to what we see. And also related to that, the degree of centralization or decentralization of decision-making and oversight. And of course, then, the context is very important, and the context will vary considerably from place to place. Whenever I leave out this water cycle figure, somebody will ask a question about it, so I have inserted it here. And its importance to many of the presentations I give, and to us in Arizona in particular, is that much of our water comes from aquifers. About 40 or more than 40% of the water used in the state of Arizona is from groundwater. And it's important for people to understand that groundwater is not a big pristine lake underground, but it is water interspersed with materials like sand and gravel, clays. And it's also important to remind everybody something that you all know, and that is no new water is created. It may change in location, quality, form, but we do have a limited amount of water, and that is a challenge for many of us. And the geographic context is, of course, extremely important. And so to give you some grounding in where I'm located, Arizona is in the southwestern United States. It's a border state. It borders with this country of Mexico. The Colorado River Basin is outlined here in this gray dark outline. It spans 7 of the 50 states in the United States, and it is a transboundary river. It is an international river. It extends into Mexico to the south of the United States. And the Colorado River is a very important water source for Arizona and the southwestern United States. In fact, it's estimated about 40 million people depend upon water from the Colorado River for use for drinking, agriculture, recreation, for support of our communities. And so the Colorado River Basin, as outlined here, is a very important basin. The river is highly managed. Water is transported out of the basin to areas like Los Angeles in Southern California and other large western cities. Here is a photo in the middle of Hoover Dam. Some of you may have visited Hoover Dam. And behind Hoover Dam is the storage reservoir known as Lake Mead. And that figures very prominently into the shortage conditions, the limited flow conditions that we're facing in the Colorado River Basin. And not only do we have 7 states in the United States sharing the water, and the US states have a lot of autonomy when it comes to managing their water resources. But within those states are sovereign tribal nations. And so this map on the right shows how 10 tribes that are along the Colorado River view the boundaries, because some of them span multiple states. So it's a very complex transboundary river system. Now, one more point of context is this context of wicked water problems. These are big problems that don't have a single solution to them and don't have a simple pathway to resolving them. And there are many reasons for wicked water problems, and often they're connected to other problems, bigger problems such as geopolitics, poverty, climate change, but also there can be large economic burden associated with addressing them. There are many people involved and maybe opinions involved about what to do, and often there's not complete, or sometimes there's even contradictory knowledge. And so they're not readily solved, and much collaboration is necessary for addressing wicked water problems. And it really requires collaborative, interdisciplinary work to try to create resilience for our communities. And process, which is something I'll touch on and come back to at the end, is very important for addressing these problems. I'll note that at different places in the presentation, I may be providing links, and the conference organizers are welcome to post my presentation in PDF form, and I will be sure to send them a copy of the final version so that they can do so. So these links are available to you. Now, I do speak and write about some of these wicked water problems of the Colorado River Basin. And on this slide, you'll see 4 of them that I talk about. The imbalance of water demand and supply in the Colorado River Basin, groundwater overdraft and invisibility, lack of water for nature or environmental flows, and in some places, lack of water and water infrastructure. Other places, it may be aging infrastructure, but there are areas in the United States, tribal nations. The photo to the bottom right is a photo from the Navajo Nation. Some households lack access to running water. And today, I'll focus on 2 of these wicked water problems: the imbalance and groundwater overdraft and invisibility. Now, the Colorado River is not in good health. The last 20 years have shown or revealed lower than average flow conditions, and these flow conditions are not expected to improve. We are in a more arid environment. Temperatures are increasing, precipitation patterns are changing, and snowpack and runoff from the headwaters area in the upper basin, if you can see my cursor here, in the states of Colorado and Wyoming, the snowmelt is not yielding the kind of flow it had in the past. And so the reservoirs, I mentioned Lake Mead, shown here again in this lower photograph. The reservoir levels are low. These are very large reservoirs. And up above, I show the other dam, behind which is the other large storage reservoir of Lake Powell. And every month, the Central Arizona Project, which I'll talk a little bit more about in a few moments, puts out this diagram showing the level of fullness of those reservoirs. So here you can see the blue portion for the bucket for Lake Mead is quite low. There's a lot of empty space. And the same thing for Lake Powell. And this was in April 2021. And since then, the decrease in the storage has gone down substantially and more than I think some people expected. And so the concerns about the drying conditions, the hot conditions, and the low flows of the surface water supplies are very critical and in everybody's mind. And this is a graphic here from the New York Times in June, where it was showing over time the western portion of the United States and how it's gotten so very arid and drought, in a condition of exceptional drought, this very dark reddish color. Much worse in 2021, although it had been bad in certain years since 2004, but the conditions are quite bad and great concern. And so our major newspapers in the United States, in the state of Arizona and the Southwest, have been covering the low flow conditions. And here's a headline from an Arizona newspaper: Red Alert, Lake Mead falls to record low level, a milestone in Colorado River's crisis. And so as we've passed time since April and June, in August, the U.S. Bureau of Reclamation, the U.S. agency in charge of delivering the Colorado River water, and particularly of importance to the lower part of the basin, the states of Arizona, California, and Nevada, declared a first ever what's called a Tier 1 shortage. This was an article in the New York Times. I was contacted by many reporters from across the country for quotes. And the important thing here is that we are in a bad situation. We don't know that we're going to have a wetter cycle like we did in the 1980s and 1990s. And so we're really having to talk about some major changes in water availability, particularly for some farmers, also potentially over time to some cities, and having to conduct a planned renegotiation for some guidelines on sharing of shortage, inability to deliver supplies as had been accomplished in the past. And so this is a report from August of 2021. And if you were to compare with that April figure I showed you, the level of fullness of the reservoirs is declining, and the shortage was declared because the level would decline below a trigger point of a 10, well, this is in feet, 1,075 feet above sea level. And so we are in a different situation where we've been relying on our savings account, our water and storage, and you can do that for just so much. If the inflows are not at a good enough level, the level of storage will decline. And this figure here shows what has happened to these Lake Mead elevations since 2000 and the projections for the next few years. And the projections are not getting better. The U.S. Bureau of Reclamation puts out a study every month where it looks for 24 months into the future, and the projections in terms of probabilities of getting to the lower capacity levels are significant, and significant not only for water deliveries but also for energy. And this is a conference about energy as well. And the water elevation, the levels of water in those two storage reservoirs, Lake Mead and Lake Powell, may become so low that hydropower can no longer be generated. And there's a risk of that happening as early as 2023 for Lake Powell. And this hydropower is very important for energy users in the region. It's lower cost than almost any other supply. And so the dislocations associated with reduced energy, hydropower, are important as well and of great concern. So we have this big issue of reduced surface water supplies. Now, I should note that surface water is not the sole source of water for many of these communities, and and water users. Some have the opportunity to use groundwater, and particularly in Arizona, where those cutbacks in water deliveries are going to affect irrigators in the central part of the state, they do have the ability, according to law, to go and utilize groundwater, return to more groundwater use. But that has its problems as well. And so I want to now move into the implications of the shortage conditions for central Arizona and the groundwater use by irrigators and communities in that part of the state. And this is another version of the map of the Colorado River Basin, the upper basin in green, the lower basin in a tannish color. I live here in Tucson, Arizona, in the south central part of Arizona. And in Arizona, we have a system for managing groundwater in certain parts of the state in these colored areas. And I'm going to be talking about this Casa Grande, which is the largest city in the area, and Pinal active management area for a few minutes. And so, as I said, we have different sources of supply. We utilize groundwater in the state. We have in-state rivers aside from Colorado River water available, and we use reclaimed water. And about 72% of the water use in the state is agricultural water use. Municipal use is the most rapidly growing part. And the Central Arizona Project was built to take water from the river, which forms the western boundary of Arizona, pump it uphill into Central Arizona. And the Central Arizona Project is a large line canal. It's open, it travels many kilometers and pushes water uphill, and is the largest user of electricity in the state of Arizona. And the irrigators in central Arizona, because of the priorities that have been established in water deliveries within the Central Arizona Project, are the ones who are going to be cut because of these curtailments in Colorado River water deliveries through the Central Arizona Project that will occur beginning in January of 2022. And this Central Arizona area is one that has had experienced large reliance on groundwater over the years. And this cross-section shows some modeling results from our Arizona Department of Water Resources, and shows that the water is quite deep, which means it's more expensive to pump. It's in the growing areas of cities, not the agricultural districts. The water is more shallow in these orange areas. And so there is a big problem of water availability in terms of groundwater for that region. It's affecting the farmers in terms of having to install more pumping capacity and incurring increased costs. But it's also affecting the ability of the region to grow. And there's a stakeholder group looking at that. There's a visual guide that my water center put out. If anybody's interested, it's available on the website. So a big problem, working on solutions. And so this brings me toward the end of my presentation, this importance of searching for pathways to solutions and the importance of developing information collaboratively, partnerships across and within regions, considering and implementing the many options, which include things like large-scale desalination, although we're not by an ocean, but perhaps in partnership with others, and then doing other things at the more individual level. And the importance of process, long-term efforts to inform, educate, communicate, and work on solutions are also very important. And I just list here some of the contributing factors to developing solutions. And some of it is being able to share lessons learned and developing the relationships, which often depend upon eating with your partners. And of course, during the pandemic, we have not been able to do that. So I'd like to thank you. The work must continue. Thank you for listening, and here is my contact information. Thank you very much.